Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh to my lecturer and my fellow friend. We are from Group 1. Today we will be present about topic 7 projectile. Before we start, I would like to introduce my group member. First is Abdul Naif bin Muhammad Zuki, which is me. Second, Ahmad Farhan bin Farizal. Third, Fernandez Unamuno. Fourth, Losley Jimbun. And the last one is Muhammad Amirul Ashraf. Next, we go to the introduction about the projectile. A projectile is a body which is propelled or thrown with some initial velocity and then allowed to be acted upon by the force of gravity and possible drag, ignoring a resistance. Okay. The maximum outward distance reached by the projectile is called the height. The horizontal distance traveled is called the range, or sometimes it can be called distance. And the last, the parts of the object travel is called its trajectory. For the next slide, I would like to present about graph of projectile. That you can see at the left, this is a graph for projectile. A projectile commonly has horizontal and vertical line. For the horizontal, it is constant that we call the range, or sometimes it will be a distance. For the vertical, it is changing due gravity. Okay, if you can see at the top, it has a arrow that we assume is the maximum height. Next, the ball moving from top into the ground. The gravity for the projectile is 9.81. The objective for the projectile is to investigate projectile motion due to gravity, influence, and conservation of energy principle. Next, to determine the distance traveled by the initial movement of golf and squash ball throughout a sliding platform, and practical freefall movement to then ground under the action of gravity. That's all from me. Next, I will be passed to my friend. Thank you.
So my name is Loxley. Now is the slide of the about observation. So the first we can see the mass of gold ball 1 is around 0.0468 kilogram, and the diameter is around 0.04275 millimeter. As the golf ball 2, the weight of the ball is 0.0460 kilogram, and as the diameter is 0.0270 millimeter. This ball, they have not having a same diameter and also their weight. As the third of type of a ball, the mass of the squash ball is around 0.0239 kilogram, and the diameter is 0.0390 millimeter. As the platform, the meter of the sliding platform is around 0.025 millimeter, and the distance h1, the height one, is 0.62 millimeter. The distance between two platforms of the x1 is 0.05 millimeter, and the distance of h2 is around 0.835 millimeter, and the angle of going the throw of the ball is around 46 degree. As for the second page of the observation, two golf recoil allow us to see if similar objects behave, they have a same condition. In other words, two golf balls used to support the theory that the mass did not affect the projectile motion. A golf ball travels further than squash ball. A golf ball and a squash ball have a different weight. This is lead to squash ball is a shorter travel range, possible due to lighter mass and a smaller diameter. As you can see, this formula is I equal 2 over 3 mr square root. This equation is used for thin and hollow ball, indicate that more energy loss during translation, resulting shorter travel.
During the experiment, we measure how long golf ball 1, golf ball 2, and squash ball travel. We do it 3 times and take the average. Next, we will continue to the calculation. Point A to B, energy conversion rolling motion. At point A, the ball starts from rest and has only a potential energy, which is PE equal to mgh. As it rolls down to point B, that potential energy is converted into both translational and rotational kinetic energy. The total kinetic energy is as equation below. Equation below show that each type of ball has a different moment of inertia. We can use this equation for energy conversion, but if there is no sliding, we can use U equal to omega R to substitute and solve for velocity U at point B. So, velocity at point B will become this equation below. This gives us the velocity of the ball at the end of the ramp at point B. Next is the second part of the calculation. Point B to C, free fall projectile motion. From point B, the ball becomes a projectile and follow a curved path until it hit the ground at point C. We will split this motion into vertical and horizontal component. The first equation is h equal to ut sin theta minus 1 over 2 gt square, where g is 9.81 meters square per second. And then we will integrate this equation and v will equal to u sin theta minus gt. Now we have time, we calculate the horizontal distance L equal to ut cos theta. So using the velocity from point B and the angle, we will get how far the ball lands from the ramp. In conclusion, from A to B, the ball rolled at giant speed, and from B to C, it behaved like a projectile until it hit the ground. This is the calculated result for the experiment. In conclusion, we applied energy conservation to find the velocity at point B and used projectile motion to calculate time and distance during free fall. This analysis helps us understand how different balls behave when launched, depending on their shape and mass distribution.
Okay, so next for discussion, first one is result compare. Squash ball have shorter distance against golf ball because the squash ball is lighter than golf ball and high air resistance. Okay, so next is factors that affect the result of time and distance. First is mass. The heavier it is, the further the ball travels. And second is air resistance. The higher air resistance, the less distance covered. And number 3 is initial velocity. The golf ball BDJ2 started from slightly higher point compared to other balls. So number 3 is experiment versus calculation results. So when doing the experiments, some people may have low reactions during the ball starts to launch to it hit the floor. So it causes the time that have been taken is not very precise. So because it's errors. And number 2 is misunderstood the formula. Since the golf are made to reduce the air drag and it was not included in the calculation, so the calculation may be accurate but other factors need to be considered. And for mass and inertia, heavier ball tend to conserve more energy. Energy is split between translations and rotations due to moment of inertia. For solid sphere, I equal to 2 over 5 mr squared, and for hollow objects, I equals to 2 over 3 mr squared.
Assalamualaikum. My name is Muhammad Amirul Ashraf bin Muhammad Khairi. Okay, today I will answer for the question 1 and question 2. Okay, for the first question, how and when do you think moment inertia of the object affect the result? Okay, for the answer, an object with a higher moment of inertia will roll more slowly at the bottom of the ramp because more of its energy is stored in rotational motion. Okay, next, a ball with a higher moment of inertia will have a lower linear speed compared to a solid ball of the same mass and size. Okay, this result is in a shorter projectile range after leaving the ramp. For the next question, explain 3 applications of projectile. Okay, first, in sports, when a footballer kick a ball or a golfer hit the ball, they are using projectile motion. The path the ball takes through the air depends on how it's kicked or hit, and this helps players control where the ball goes, whether it's for scoring or passing. Okay, second, in the military, projectile motion helps in calculating how bullets travel. Because of gravity, bullets don't move in a straight line. They follow a curved path. Understanding this helps in designing better weapons and improving accuracy. And last is rocket science. When a rocket is launched, it starts with a strong initial velocity. After launch, gravity pulls it downward, and this creates a curved, projectile-like patch, similar to other projectiles, but on a much larger scale. Okay, for the conclusion, from this experiment, we are able to clearly see how projectile motion works in real situations. We found that things like mass, shape, and air resistance really do affect how far and how fast an object moves. Of course, there were some difference between what we calculate and what actually happened, and that's likely due to things like air drag, friction, or even small human errors. But overall, the experiment gave us a better understanding of how different physical properties affect motion. And this kind of knowledge is really useful especially in areas like sports, engineering, and solving real world physics. That's all for our presentation. Thank you.